At 4,000 meters, the ground here is cracked into plates, like the bed of a lake that forgot how to hold water. And the strange thing is this: the animal now being used to heal it presses more gently on that earth than the animal that broke it. A sheep walks on hard, sharp hooves. A guanaco walks on soft, padded feet, 2 toes cushioned like a dog's paw. On soil this fragile, that difference is not a detail. It's the whole story. This is the Chilean Altiplano, the high plateau, where the Andes flatten into a cold, thin-aired roof over South America. For most of the last century, it was sheep country. And for most of the last century, the sheep were quietly killing it. The question this project asks is deceptively simple. Can you heal a broken landscape not by engineering it, not by planting it row by row, but by bringing back the animal that shaped it in the first place? And can you prove it in 3 years, not 30? The guanaco is a wild camelid, a lean, russet-coated cousin of the llama, with dark eyes and an almost absurd elegance. It has grazed these grasslands for hundreds of thousands of years. The plants here didn't just tolerate it, they evolved with it. To understand why the sheep failed, you have to understand what the plateau actually is. Beneath the dry grass lie the Bovedale's high wetlands, spongy cushions of peat and moss that soak up snowmelt and lock away carbon, drip by drip, over millennia. Sheep don't graze the way native animals do. They crop the grass to the root. They return to the same wet patches again and again, and their hooves punch into that soft peat until it drains and dies. What took 10,000 years to build, a herd can unstitch in a decade. The obvious fix was the human fix. Fence it off, fertilize, reseed by hand. It's been tried across the Andes for years, and at this altitude, in this thin, cold air, it mostly fails. Bare ground reseeded by people tends to stay bare. So in 2021, a team working under the banner Rewilding Gondwana, named for the ancient supercontinent, these grasslands, remember, tried the opposite. Instead of doing the work themselves, they hired the guanacos, not wild-caught animals. That would be its own kind of damage. Locally bred ones, raised in the region, adapted to this exact cold and this exact thinness of air. Roughly 600 of them, released in managed groups across a target of more than 10,000 hectares. And here is the elegant part. Guanacos don't graze like sheep. They move. They nibble a patch, then wander on, rarely returning before the grass has recovered. They avoid pulping the wetlands. Their soft feet aerate the soil instead of sealing it. And there's a bonus almost too neat to believe. Guanacos are tidy. They leave their droppings in shared communal piles, natural, concentrated deposits of fertilizer, and crucially of native seed, carried in the gut from healthy ground to broken ground. So they don't just graze the land. They seed it, they fertilize it, and they aerate it, the 3 jobs the human reseeding crews were trying and failing to do by hand. The animal is the machine, but a good story is not proof. Andean grasslands are littered with beautiful theories that never delivered. So the team did the unglamorous thing. They measured. They fenced off control plots grazed by sheep, right beside plots grazed by guanacos on identical soil at identical altitude. Then they counted plant species, ground cover, bird activity, and buried in the soil the thing everyone actually wants to know about: carbon. Carbon is the quiet prize here. A living grassland pulls carbon out of the air and pushes it down into its roots and into that spongy peat below. A dead, compacted one does the reverse. It exhales, releasing centuries of stored carbon back to the sky. 3 years is a blink for a grassland. Nobody expected a miracle. What they were looking for was a direction, a measurable difference, one way or the other, between the sheep plots and the guanaco plots. On the guanaco ground, native plant diversity climbed. Bare soil shrank as bunch grasses and cushion plants crept back across the cracks. The Bovedales, the wetlands the sheep had been draining, began slowly to hold water again. Where the grass came back, so did the small things. More insects in the sweep nets, more ground-nesting birds. The lean, dog-like Andean fox slipping through at dusk, following the return of prey. Life, it turns out, arrives in a sequence, and it starts from the roots up. And the carbon in the soil measured, sampled, sent to a lab, not guessed at, trended upward on the guanaco plots relative to the sheep plots. Not a landslide, a 3-year head start. The difference between ground that breathes out and ground that breathes in. It's worth being honest about the limits. 3 years is short. Some of the gain could be good weather, not good grazing. The carbon signal is real but early, and it needs a decade to be sure. This is a promising direction, not a finished victory, but the direction is the point. Because the sheep plots on the very same soil were not improving, they were flat or fading. And in ecology, when two paths diverge that clearly, that early, you pay attention. There's a deeper idea underneath all of this. For a century, we treated grazing animals as the enemy of grassland, as the thing you fence out to let land recover. But grasslands never wanted emptiness. They wanted the right animal, moving the right way. The guanaco was never a passenger on this landscape. It was a gardener. Remove it, and the garden falls apart. Return it, and given time, given honest measurement, the garden remembers how to grow. 10,000 hectares is small against the scale of the degraded Andes' millions of hectares, thinned and cracked by a century of the wrong hooves. But that's what a proof of concept is for. Not to fix everything at once. To show, on measured ground, that a thing works. And if it holds, if the 10-year carbon numbers confirm the 3-year ones, then the map of what's possible changes. Not more machines, more fences, more imported seed. Just the patient return of a native animal, doing the work it was built for, at 11,000 feet. We've pulled the full breakdown together, the plot-by-plot data, the carbon methodology, and how honest the 3-year numbers really are in the link below. If the idea that the fix was the animal all along stays with you, that's where to go.